Thanks for attending my session about high-performance event-sourced microservices with Akka and Play. I know that there are many other sessions that are also very interesting, so thanks a lot for coming to my session. First, who am I? My name is Dominik Dorn. I'm a freelance software engineer. I'm also the leader of the Java Vienna meetup and the playframework.wien meetup group. And I'm also an integrator in the Play Framework project. I'm particularly interested in Scala, Akka, Spark, Play, Cassandra, Kafka, and Postgres, and of course also Java. The talk today will feature Scala examples. A short overview. We will take an introduction to event sourcing. I will give you a short introduction about actors and how actors are working in Akka. Then we will take a look at how event sourcing is done with Akka persistence. I will give you a quick introduction to CQRS. Then we will take a look at how to do clustering with Akka and Akka persistence. And in the end, I will show you how I structure my code base and my dev environment to be have a good experience. Okay, intro to event sourcing. Who ever heard of event sourcing before? Please raise your hand. Who is doing it in his work? Okay, two, so three. Good. We will take a quick look why we are doing this, how it's working, what are the essential parts of event sourcing, and yeah, let's get right into it. Why should you take a look at event sourcing? Basically, event sourcing can be high performance. You have immutable events, so that means no locking, no concurrency issues. You're always writing to an append-only journal, and due to that, you also have increased write performance because there is no locking in the database whatsoever. You don't need to care about an object relational mapping, so there's no Hibernate or no juke or anything. And of course, you always have a full audit trail, so you can always see what events happen in the system and how did I come to the state that I'm now. This is especially important also for government issues like the new GDPR law. And of course, you can also use it to debug your application and figure out why is this bug happening, and you can replay events. Examples for event sourcing, your bank account or the PayPal account you maybe have is based on event sourcing. Like your bank account is always, it stores event like this amount came in or this amount get out and it went to this or that account. Git is an example of event sourcing. All the order tracking applications you know from the internet, like when you order something from Amazon and you look, okay, where's my package? That's an example of event sourcing. Kind of example is everything blockchain related, because the blockchain is an append-only journal. And your databases, the Postgres or Oracle, they are doing it in a kind of way behind, because there's the transaction log that's basically storing all the changes in the database. But there you're just storing that, okay, this value has to change to that value, so you're losing the meaning. How does event sourcing basically work in your application? What you have your user, and let's say your user wants to register himself on your website. So what he's doing, he's filling out a form. This sends a request to your web server. Your web server then delegates to a controller, and in this controller you're basically creating a command. And this command is then sent to a command handler. The command handler does all kinds of checks to see if it wants to accept this command or wants to reject it. If the command handler is chosen to accept the command, then this command is turned into an event, and this event is then stored into an event store. After the event is stored, the event is sent to one or more event handlers, and those event handlers can do whatever they want with this event. Like, for example, send an email to the user to say, welcome on our platform, or create the user in an authentication system like LDAP. And of course, there should always be one event handler that's communicating back to the controller, and the controller then sends back the response to the user. Commands and events. So as you already heard, we have command handler and event handler, and of course we also have commands. So a command is something that the user wants us to do, like I want to register myself or I want to change my name. And these objects are sent to the command handler, and the command handler then changes them into an event. So an event is something that has happened in the past. You cannot change it. It will always stay like this in your database, and you should always name it in the past. So register user gets transformed to user registered. The event journal, as I said, it's a immutable database. It's append only, and it's the single source of truth in your system. So there is no other part where any logic or truth lies. It stores the event. It groups the events by an entity ID or persistence ID, and and of course every event has a sequence number. How does this look like, simplified? You can imagine it like a table like this. You have a column that's the entity ID, where you say, okay, these are the events for entity of user 1 or user 2, and every row has a sequence number. And of course, you also store the type of the event, like user registered or name changed. And on the right side, you can see the payload. Here it's in JSON formatted. Like you see, I registered myself and I made a mistake in writing my name, and then I just changed my name to be correct. Okay, what does the command handler do? Like I said, it's enforcing constraints. For example, it could check if there's already a user that has this email address in our system, so that's like the unique constraints you know from your database system. It's also responsible to for persisting the event to the journal. That's basically here, this persist to journal call. And after the event is persisted, you can invoke other event handlers like send welcome email. The command handler can delegate to event handlers, but it doesn't have to. For example, if it's rejecting the command. Yeah, so you can have one or more event handlers attached to a command handler, but yeah, it's up to you how many you create. Okay, event handlers, they work on the events, so they are quite simple. Basically, we have now an example of an event handler that's keeping track of the registered emails in our system. And as you can see, it's just handling this user registered event and adds the email to the list of registered emails. So we can check in the command handler that no user is added twice. A short introduction to Akka and actors. Who used actors before? Please raise your hand. 1, okay, 2. So who heard of actors or the concept behind it? Okay, a lot more. Okay, thank God. Good. I have a comparison between actors and humans because they are quite alike. Actors, they have state, they have fields, they have lists, they have integers inside them. Humans, we have properties. I have not so much hate, but the more rate and some knowledge. Actors just communicate via messages. We humans, we communicate with all kinds of things, like we call people, we send them SMS, we send them letters, we just stare at them if they're doing something bad, or we can touch them. Actors, they live in an actor system, and we humans, we live on planet Earth. Let's talk about creation. Actors are created in an actor system, so what you're doing is you're creating a new actor system, and God created planet Earth for us. If you want to make a new actor, you're calling system actor off, and props is like a constructor for an actor, and God just creates the humans. And if you want to make a child, you all know how this works with humans, but in an actor system you just make a context and child off and say, okay, this is the constructor of my actor, and you will get a new actor. How do we get information? We humans, we just shout to each other and say, hey, Mike, what's the score of the game? Or Steve, actually. And he will shout, yeah, it's 3-2 for Manchester. And in an actor system, you have to send them messages. To send a message to another actor, you use the tell method. and the getCurrentScore in this example is the type of the message. And of course, to answer this, you also use the tell method, and here you can see if an actor receives a message, there's always a method sender, and that you can use to answer back to the actor that sent you a message. And in this case, it's the score of the game. Actors in Akka. Actors in Akka are simple classes. Like here we have a class human. This extends Akka actor actor, and this actor can have state. And the great thing about this thing is that you don't have to worry about concurrency. You don't have to worry about that another actor is changing the state in my actor or another thread. And you have a concurrency model where you don't have to really care about concurrency. An example of how an actor handles messages would be like if the actor receives a command, give name, and here then just sets the state and replies with another message. And down here you see, okay, I created this actor Adam, and then I just gave him the name Adam. Good. Wow, I'm actually a little bit too fast. Persistent actors. How does a persistent actor lifecycle look like? Okay. Again, we have where is it? Here. We have our user. Our user wants to register himself on our website. Our web server calls our controller. Usually you write a small adapter between your controller code and your actor code. What then happens is this adapter calls a user manager actor. That's also an actor that you create. That's basically managing all the users in your system. And this user manager then either creates a new actor or looks it up and sends the command to him. In case of the register command, he will probably create a new actor. We can see the user can have many actors, many childs. Actually, I think the battery is running out, but okay. And then this actor, the user actor, is handling the message and decides what to do on it. And the user actor, of course, can create own events, and those events are then stored in the event log. When the event is stored in the event log, the user actor can also invoke other actors, send messages to them, and those then can do stuff like send an email. When the message is persisted, the user actor, of course, also answers back to our adapter. The adapter goes back to the controller and delivers the result to our user. The important thing is if our system at one point crashes, the user will the user actor will recover from this journal and replay its state. So it's it's persistent. So you will not lose any changes. How does a persistent actor manager look like? It's just a normal actor class. If you are using the Play framework, you can even do inject other components of your system with dependency injection. What does every persistent actor have? Every persistent actor has a persistence ID. That's basically the key that is used to store the events of this actor in the journal. And it has a receive command method and a receive recover method. So the receive command method gets all the commands or handles all the commands that are sent to the actor. And in the receive recover method, you are basically handling the events of this actor. So you're restoring state. If you have a user manager, you probably don't have any state in your in your actor, and this can be empty because you're just forwarding the messages to your children. Here I made a small helper method that's make it easier for you to keeping track of the actors and creating them and so on. Good. How does a normal persistent actor? It's basically the same. We just have the only difference here is that the persistence ID is dynamic. So the first user will get, for example, user -1 and the second user -2, and the rest is the same. How does a command handler look like in a persistent actor? It's a little different from the example I showed you before, but also quite easy. So we have here a register user command. We extract the parameters from the case class. We then do some checks maybe that we want to enforce, like, okay, I only register users where the email address is like at least 5 letters, or I can also do checks on the name. And if all those checks pass, then I'm persisting my event to the event journal. And as soon as this happened, I get back this callback, and I can basically invoke my receive recover method that is then handling the event. And the good thing about using the receive recover method is that you have the same logic when you create the event, as well as when your actor starts up after a crash or because you rerouted your system. What you can also do is like send the email to the email actor, and of course you should always answer the actor that sent you the message, so he knows that you're completed with your work. Yeah, is another example. You can also just send the a different kind of message back. Here we see that I check the constraint, for example. If a user is sending the change name command, I will check is the command that I got, is it already applied? Like, is the name already the same? So I don't want to store the same event twice. Yeah. Good. How does the event handler look like? It's quite simple. You have a method receive recover, and this method is working on the incoming messages. It looks okay if the type of event that I'm handling right now is a user registered event, then I'm setting the email and the name here. If the type of the event is name changed, and I just change the name. The important thing is that in the receive recover method, you're not allowed to do any logic, because those are events, and events are facts of the past. So if you do any logic here, you will get a very unstable system, because it's not strict anymore. You might now think, okay, if I'm doing this event sourcing, what if I have like 1 million events and I change like this user a lot of times? And then that, in a traditional way, it would mean that every time you load this user, that you have to process 1 million messages. Of course, that's not something that you want, because it would take some time. That's where snapshots come in. And snapshots work like this. When you're creating the event, after you persisted it, you can just invoke a method that you create where you check, okay, if the sequence of this event is modulo 1000 is 0, then I will create a snapshot, and that's basically just like invoking this save snapshot with any object of your choice. And to recover from a snapshot, it's also quite easy. You just add another type of message in the event handler. The message that you get is the snapshot offer. Snapshot offer contains some metadata, like, okay, when was this snapshot taken, or what's the sequence number, and the data that is stored in the snapshot. For example, here we have 2 strings, and when I'm taking this snapshot, I'm just restoring the email and the name at this point, and the snapshot plugin of Akka takes care that the messages that were received after this snapshot then get handled like normal in the event handler. You might now think, okay, how scalable is this thing? Like, if I have millions of records in my system, then at one point I will run out of memory. That's why you set a receive timeout. A receive timeout is like a method that makes sure that if no message is received in this actor after a certain period of time, it will send itself a message of type receive timeout, and then you can do something like stop yourself, or I don't know, ask your supervisor, hey, do you have any work for me, or something like this. Okay? So in this example, after 3 seconds, our actor would after 3 seconds of inactivity, our actor would receive a receive timeout message and would then just stop itself. Okay, some best practices. The most important thing is creating protocols. I'm always doing this like this. I have a companion object of the user. If you're from the Java world, that's you will not have companion objects, but just static inner classes. And in this companion object, I create 3 different kinds of child objects. One is an event object, one is commands object, and one is queries objects. This helps you to program in an easy way in your IDE, because then you can just use the completion of your IDE and you don't have to remember, okay, what are the commands that I can use with this actor, or what are the events that I get back. Quite important are also the seal traits. A trait is like an interface in Java, and a seal trait is it means that this interface can only be implemented basically in this class, and I can then use it like an enumeration and be sure that I catch all the cases. I will show you an example of this a little bit later. So let's take a look how an event would look like. Here we have 3 examples. One, we have a user created event where we have the email and the name, and of course it's extending this event class. Then we have the name changed event, we also seen this, and another example where we added a friend. Okay, like if you're Facebook, we can add a friend. And what's the, okay, now we come to the seal trait. Yeah, this seal trait, why is it important? Because if you use seal traits, IntelliJ or the IDE of your choice can offer you to generate the possible types of messages that you're working with. Another good thing is that this is not only working in IntelliJ, but even the compiler is telling you if you forgot to add to handle an event. For example, in an application I created, I was adding doctors, and here it told me, okay, you forgot to handle the event when you delete a doctor. That's quite helpful, because you prevent yourself from making mistakes. Commands and responses. Commands are also seal traits in my applications, because then I can, when I'm invoking my actor, I can just say, okay, I have this kind of commands, and the actor can also work on them. And I also create always traits with responses for every command. So if I send the actor a command of type create user command, then when I'm handling the responses from this actor, I can also always say, okay, the only possible answers I get from this command are user created response or user creation failed response. The same thing we have for queries. I will show you later the command, or actually in the next slide, command query responsibility segregation. So we also have queries in our system. So commands are things that our system should do, and queries are things that we ask from our system. Like if I say, system, please give me all the email addresses of my users. And of course, you should also create here seal traits for the same reason like I told you before. The nice thing in Scala is that, or actually that's the same thing in Java too, that you can inherit from multiple traits and then can reuse, for example, this user not found message. Command query responsibility segregation, CQRS. Who heard of CQRS before? Please raise your hand. Oh, almost everyone. So the basic idea between in CQRS is that you split the actions in your the things that your system is doing into actions, so commands, so things that should change some state or start some process, and queries, so stuff that you want to know from your system. It's good practice to divide your code base according to those two kind of use cases. And the great thing is that if you do that, you can also create optimized data stores for the various queries you have in your system. And if you want to, if you have a really high load on your system, you can even create separate microservices for your read side and for your write side. Example of a CQRS query would be that I want to get the name of all the users in my system. And I will show you 3 different approaches. The naive Akka way is like ask everyone. Then we will take a look at the event log, and then I will show you how you can create custom read sites. Okay. Okay, the ask everyone approach. What are we doing? Basically, we are creating an actor that gets a list of all the IDs of the users we have in our system. And what he's doing, basically, he's sending a message to the user manager. I call it here aggregate, and tell that for every ID in the system, I tell him, hey, give me the user data. And the manager then forwards this message to all the user actors, and they will answer back. And you see here that I then handle the answer the actors give me, and basically I have a list of IDs that I'm still waiting for an answer, and I have the data that I'm interested in. And what I'm doing, I'm adding the answers from the actors that I'm asked to the data I have, and remove the ID of the actor that sent me this message from my waiting list. And at one point this waiting list will be empty. That means I got all the answers I was looking for, and I can send the accumulated response to the person that asked me in the first place. Alternative to this approach would be to use Akka persistence query. It's basically a plugin that you can just add to your build, and to your depending on which journal backend you use, there are different implementations. For example, this one is the implementation of the Cassandra journal. And what you're doing is basically you create a read journal with this Akka extension, and then you basically you create a method that is working on an Akka stream. And in this example, I will show you now the method. What we're doing is we're invoking this method that is giving us a future, and when this future is finished, we will basically send the answer of this future to ourselves to know that we finished loading all the data. And the kind of answer that we are expecting from this future is a done, because we're mapping it here basically. So how does this work? Who heard of Akka streams before? Please raise your hand. Okay. Good. Akka streams is who heard of reactive streams? Okay, a few more. So reactive streams is a new initiative that's basically working a method of working with data streams, and you have features like back pressure or throttling. And Akka, it's now I think of JDK 9. It's part of even of the JDK, and Akka streams is an implementation of reactive streams. And I fear it's too much to explain in this talk, because it can fill an own talk by itself. But okay, let's take a look how this basically works. So what we're doing is I have different kinds of stream stages, and one stage is like a a stream consists basically of a source, like where you get data from, then of various stages where you basically can filter or transform the events, and of a sink. So basically, where are you putting the events in the end? So we have here these all current user IDs. That's a source where I'm basically asking the regional, okay, regional, please give me all the persistence IDs in my journal. You see here there's a difference between current persistence IDs and persistence IDs. That means current persistence IDs is a stream that will stop at one point when it's done with all the persistence IDs. And here is a source that will never stop, because as soon as a new persistence ID is added to the system, it will publish a new event. Then we have a filter. basically what I'm doing is, okay, I get all the persistence IDs in my system, but I'm only interested in those where the key name starts with user dash. So user 1, 2, 3, 4 will be matched, but not something else. If you are thinking in a relational database way, then basically a source is the same thing like a from, like I'm reading from this table, and this is basically the select part. Okay? No, it's actually the where part, like I'm filtering, give me all events where the name is like this. Okay? So what we're doing then in our method is basically we're selecting all the IDs from our event stream. We then filter it through our filter, and what we're then doing is, okay, we now got all the persistence IDs. What we're doing is we join those IDs and look up all the events of those persistence IDs, so all the events of those actors. That's what we're doing here. So till here I just got like user 1, user 2 and so on. And here now I will get a new user, user registered and name changed and so on. And what I'm then doing, this is basically the sink, so where my data is going to end up. And I'm just sending my actor again this event so that I can handle it. How does this then look in my event handler? The only difference is that basically I have an event envelope where my event is basically packaged in, and here it's the same code like before. As soon as I get this done message, I know that I have consumed all those events, and I can send back my answer to the guy that asked me the question. This now would be a solution where you store all the data in memory. Of course, you maybe don't want that. Maybe you have like a legacy database that you need to fill. Then you could do it like this. This is just some pseudocode, so the SQL state, this thing will probably not compile. I'm not sure if it's even exists, but it should give you like an idea. So what you could do is, when you're handling, for example, the user registered event, you could basically create a new entry in the table of users. And if you're handling the name changed event, you can just update this table. The same thing you can do with any other system, like you can update or insert data into LDAP or into Elasticsearch. One thing that is interesting if you're doing the Akka streams thing is that there are some delays there, because most journal plugins basically go back to the database and poll it all the time. Is there new data here? There are some plugins that support a real streaming way where they don't have to poll, but most, like the Cassandra thing, it has to poll all the time. And what you can do is that you create a write event adapter, and in this write event adapter you basically can tag the events that your system is creating, and with this tag then you can just get all the events that are tagged with this tag, and you don't have to look through all the persistence IDs and then get the events from those persistence IDs. And a good idea to make this even more instant, because like in my project at home, I had like a delay of like 2 seconds before the event handler got notified about a new event. A good idea is that when you're in the command handler, after you processed and persisted the event, you can also publish it to the event stream. The event stream is basically a message hub in Akka, and in your event handler you can subscribe to this event stream, and then you have like 1 millisecond update time in your actor, and your data is always up to date. Good. Clustering. To do clustering in Akka, there is a Akka cluster module. The idea behind this is that you use cluster sharding to place all the aggregates on different routes. So a user would be an aggregate in our case. What you shouldn't do is that you shouldn't distribute the contents of your aggregate. So like if the user has a pet or something, then the user and the pet, they should stick together and come on the same node, and you shouldn't distribute those because then you will just have problems. If you have read sites like this one, you should use a cluster singleton, because else you might run into concurrency issues, because two handlers are handling an event and starting to overwrite each other in the database, and you don't want that. Yeah, and the rule of thumb is when you're creating your sharding regions, that each region has at least 10 each node has at least 10 regions. So if you're calculating the total number of sharding region, it's like 10 times the cluster nodes. Good. How does clustering with Akka look like from an architect's point of view? We have again the same example where you have the user that is registering on the website. We have our controller, we have an adapter, and we have the user manager that we've seen before, that's responsible for creating and delegating actors. And what we now have is some intermediate actor. Here I called it user region. That's basically a proxy that will then decide, okay, I got a message of this type, and I have some methods how I can figure out, okay, to which actor does this message belong. And then it knows, okay, I have to send this message to node number 5 or node number 7. Okay, after the user region extracted these things, the message gets delegated to the specific node, and from there on it's like normal. The great thing about Akka is that the addresses of actors, they are location transparent. So when you're working with actors, it doesn't matter if this actor is on machine 1 or 2 or 5 or 10, or if you just have one single machine. The program model is completely the same. Yeah. How do I create a sharding region? It's basically like this. You just create an object. You basically use the cluster sharding Akka plugin, and then you basically define the parameters of this sharding region. For example, this sharding region has the name user, and here I'm defining, okay, how can I create actors of this type? So that's the props. That's like the constructor, like I told you before. And here you can specify some settings like, okay, how many nodes should my sharding region have, and stuff like that. And you have to supply 2 methods. Basically, one method that is figuring out, okay, what is the entity ID of this message? So does it belong to user 1 or 2 or 100? And the second thing is a method that is basically figuring out the sharding region that I should use. So what you could do is, for example, if you have this ID, then you can use the hash code and do it modulo 100 if you want 100 sharding regions, and that's how you would do it. What you can also do is you can change the way you do the sharding at any time. So if you decide, okay, my system is growing like crazy, you can also and I have more nodes, like instead of 10 nodes I have 100 nodes. You can also adjust this method, and then your cluster will work on 1000 shards instead of 100. Okay, the only difference that you have now is that you're not creating the actors. Oh, that's the user manager. Okay, you have your user manager. This actually should be on the next slide. Please forgive me for that. What you're doing in the user manager is you create this user region with the code that I just showed you, and the only thing that you're doing now, if you get messages, is that you just forward this message to this user region, and the user region then transparently proxies the message to the corresponding shard. More details can be found in the book Mastering Akka, first edition, 2016. Even though it's already 2 years old, the book is highly accurate. And at the moment, you can buy it for the ebook for just $10 US. The printed book is like $50 US, so it's a really good deal. It has like 500 pages, so it's covering almost everything that there is to know about Akka. Good. I will show you now how I'm structuring my microservices. Basically, what I have is one big project, and in my project, what I have is a request handler and multiple modules that would correspond then to the microservices I have. For example, I have I created the pet clinic that you maybe know from Spring projects in Akka and Play, and one of my microservices is the pet clinic thing. And another module I have is the single page application in Angular. And I have another microservice that is just responsible for user management and authentication, and I could have one that is responsible for billing and sending invoices. I basically create microservices of the scope of bounded context. There are people that like to create microservices that are just around one aggregate. I think that's the wrong approach, but of course everyone has his own opinion. So yeah, that's the way I'm doing it. So basically what you have this big project. This is just for your development environment, and you have the modules. Can you see this? No. You have the modules that then get created during the build process into own Docker images, and you can upload them to your cluster and scale them independently depending on how much load you have. Yeah, the virtual host request handler is basically the way that you can access all those microservices in a convenient way in your local development environment. So basically you start up the root application, and here you're just looking at the host name header and then delegate to the roots file of the sub project and invoke the root there. This is basically taken exactly like from the Play Framework documentation, but it's a great way how you can basically start your whole environment on your local machine and test it like it would be real. Code structure. What I did is basically I structure my code first around the entity I have. So in the example we had, it would be user. Here it's now owners or pets or stuff like that. And in this package, I then create sub packages for all the actions that I want to invoke. For example, if I want to add a new user or add a new owner, I have a package that's create owner, and I have a package that is get all owners. That's the create owner is a command, get all owners is a query, and in this package, everything that is needed to basically handle this request from API's view is included. So I have the controller. It's basically just containing one method and maybe some helper methods if I need them. It's containing a create owner service, that's the adapter. This one basically also just includes one method and is responsible of bridging the actor world with the future-based world in my controller. So the only thing it does is basically here I have a method like create user, email, and name, and the owner service basically transforms these two parameters of the methods into a command object and sends it to the user manager, and then basically waits for the response of the user manager and sees, okay, I had those types of possible responses, and I'm mapping it to basically like a string or boolean or whatever I want to send to my client. And here we see the owner create. That's basically just the model class that I'm using to send back the result to my user, and can easily encode it as JSON. So what I'm doing is I create input and output types for all my use cases. For example, here you can see when I have the query that I want to get all users, I have the owner get pet command basically. That's basically the JSON that I am taking from the user, and here I have the response. That's basically the response object. Then I just here I deserialize it from JSON. Here I serialize it to JSON, and I have everything that my API consists of in one package. Good. I'm almost finished, so I wanna thank you because, like Venkat is saying, the most precious thing you can ask from someone else is not its time or its money, it's his attention. I hope you found this talk useful. So thanks a lot for coming here. Here is my blog, here is my Twitter, Xing, LinkedIn if you wanna connect. If you wanna go okay, I didn't think that you wouldn't see the URLs here, but we have the Java Vienna meetup in Vienna and the Play Framework meetup. So if you're here, please join our groups. And during the evening, I will also upload the slides to my blog. So if you want the slides, you can get them there. Good. Thank you. And if you have questions, I'm now available. Yeah. Mm-hmm. What you usually do if you mean if you change the data model, for example, in this one. Yeah. What you usually do is basically here you don't have to care about snapshots because you're consuming the events only. And if you change the data model, what you usually do is you just throw away the snapshots and recreate them. So the example that you probably mean is like where are the snapshots? Here. Yeah, you mean like if I don't want just those two fields but something else as well. Yeah. What you do is you just throw away the snapshots and recreate them. So there's a command that you can just disregard all the snapshots, or you could even go to the database and delete from snapshots and where ID is like that. Okay. Other questions? Oh, did this answer your question? For the recording, the question was if I change my data model and I have snapshots, how can I adjust them? Other question? 1, 2, 3, 4, 5, 6. Okay. I will be around the whole day. Thanks again for coming to my session, and I hope you liked it. Please use the Scat app to rate my talk and give feedback. Even if you don't like my talk, I'd like to always improve, so feedback is very valuable for me. Thanks again, and enjoy the rest of the conference. Thanks.